Now I will go through 2014 C3 surface geometry question. Part A, draw the regular pentagon and complete the given plan and elevation of surfaces A and B. Now you can complete surface C also in the plan, you cannot complete it in the elevation at this time. I have already done that on my A3 page here. So it is all straightforward. The only thing to watch out for is your scale, 1:500. As you can see, these measurements are all in meters, divide them by 500 to get your scale drawing that will fit on your page. Part B of the question, determine the dihedral angle between the surfaces A and B. Here is my line of intersection between both those surfaces. So I'm going to go to my drawing now, and I'm going to call that line of intersection line 1, 2. Both surfaces are triangular, so there's point 3, point 4. Follow them down, match up the same points in the plan. As before, to find the dihedral angle, our first step is to find the true length of the line of intersection between both planes, which in this case is the line 1, 2. So I will project an auxiliary view looking 90 degrees to the line 1, 2. Here's my x1, y1. I will then need to take my heights from the elevation. I'm going to put in a datum line at my lowest point, which is point 1. Make sure and label that. I'm going to take my heights from there. Points 2 and 4 are both the same height. And point 1 will be on my x1, y1. Now surface A then is 1, 2, 3. I will join those. And surface B is 1, 2, 4. And what I have now done is found the true length of my line of intersection, line 1, 2. So there's my true length. Next step then for my dihedral angle, I need to view my line of intersection as a point. So I will look along that true length line. And there's my x2, y2. I am then counting back my 1, 2 views to take my distances from. I am going to put in a second datum line parallel to my x1, y1 through point 3, which I will label as well. One, 2 will now appear as a point. Point 3 is on the x2, y2 as my datum line passes through it. And I have now found my dihedral angle, which you will indicate and measure. That is part B of the question now complete. Part C of the question: determine the vertical trace and the horizontal trace of the plane that contains the surface B. So this is back to our oblique plane topic now. What I will need to do, surface B, which I have called 1, 2, 4. I've labelled my 3 vertices of it. So how I will begin, I will extend out the line 1, 2 in the elevation until it hits the XY line. I will drop that line straight down, or that point straight down, and then I will extend out 1, 2 in the plan. There's my first point on the horizontal trace. I will then do the exact same thing, only this time I am going to extend out the line 1, 4 until it hits the XY line. Where it hits the XY line, I will then drop that point straight down, and I will extend out 1, 4 in plan. And there's my second point on the horizontal trace. So all I need to do then is join both points, extend it out. I'll extend my XY line slightly. And there's my horizontal trace. I will follow the very same steps now to find the vertical trace. I'm just going in the opposite way, so instead of extending them out first in the elevation, I will extend out the points in plan. So the line 2, 4, I will extend it in plan until it hits the XY line. I will then bring it straight up, and I will bring the line 2, 4 across. And that there now is a point on my vertical trace, which I can just join back to where I have point T labelled. And there's my vertical trace. So that is part C of the question complete. Next step, part D. Determine, or the dihedral angle between surfaces B and C is 160 degrees. Complete the projections of C. So I have not got surface C drawn in the elevation. As you can see, I do have it in the plan. So I need to complete the projections, in other words, draw surface C up in the elevation. Now, first thing, the line of intersection between B and C, which I have here and here in the plan. It is the line 2, 4, 2, 4. What I am going to do is go the normal way I would as if I was trying to find the dihedral angle between both surfaces. Now, this is actually the first part of the question, where we would normally find the true length of the line of intersection. I do not need to do that here. The reason being is the line 2, 4 is horizontal in the elevation. Therefore, the line 2, 4 in the plan is already a true length line. So part 1 of the question has already been done first, or step 1 of finding the dihedral angle. Now I am going to call that corner 0.5. So I have the true length of the line of intersection between both surfaces. Step 2, for finding the dihedral angle, as we've already done in this question, would be to look along the true length of the line of intersection 2, 4. And there is my x1, y1. What I can do now is I'm going to use the same data line as I already had from the earlier on in the question. This point 1 is my lowest point. There's point 1. I will take the height then for 2 and 4. And as you can see, the line 2, 4 now appears as a point. Now, next step of the question is to actually find where point 5 would be over here, which is where we're going to just look back to the question and use the little bit of information they give us, where they told us the dihedral angle is 160 degrees. Normally at this point I would have found point 5, I would go and measure my dihedral angle. So all I'm going to do is take my protractor, I'm sitting it on the surface B there where it appears as a line, and I'm measuring my angle 160 degrees. Extending it out to where it hits my projection from point 5. There's point 5. All I need to do now is project point 5 straight up to the elevation. I'm going to extend out my datum line slightly. And if you remember, I took my heights from 2 and 4 from the elevation. I stepped them off. All I'm going to do is for my x1, y1, measure the height from point 5, step it off from the datum line, label point 5, and join it to 2 and 4. There's surface C. And that is the question completed.